China just unveiled a groundbreaking AI system called WOW, the first self-evolving world model that teaches robots to actually think and move with human-like intuition. Beijing startup No-Tix Robotics launched a new $1,370 humanoid named Boomy designed for homes and classrooms. And United's G1 robot just showed off insane balance by pulling a 3100 lb 1,400 kilogram car. Robotics in China just hit another level. So let's talk about it. Alright, so China is on a serious roll. WOW, the first self-evolving world model for robots with humanoid robots and AI right now. In just a few months, they've gone from lab research to robots that can think, move, and even act almost like humans, all powered by some next-level models. The most fascinating one so far is something called the World Omniscient World Model, or simply W. It's being called the world's first self-evolving multimodal world model system. And what it does is actually pretty wild. It was developed by the Beijing Humanoid Robot Innovation Center, together with Ping University and the Hong Kong University of Science and Technology. On paper, it's a combination of a physical simulation model and a vision language model, which basically means that robots using WOW can imagine, verify, and self-correct. In other words, they can build a sense of physical intuition similar to how humans understand, cause, and effect. The idea behind it is that current video or simulation models just watch the world passively. They can see what happens, but they don't really grasp why it happens. WW flips that approach by letting the model actively interact with its environment, learn from it, and refine its understanding through trial and error. It's a 14 billion parameter generative model that actually learns about physics the way we do by doing things, messing up, and improving over time. The team behind WOW built it on something they call the Sophia paradigm, that combines large language models with diffusion transformers to generate physically accurate outcomes under language guidance. So if you tell a robot to move the cup off the edge of the table without spilling it, W doesn't just output words or animations. It predicts what would happen, checks the result through reasoning, and then refines its understanding to make the next move more realistic. It's basically a loop of predict, critique, and refine. And that loop keeps going until the robot's behavior becomes genuinely smart and physically consistent. To test all this, they created a whole new benchmark called WOW Bench. It measures how well AI systems can understand perception, reason about predictions, make decisions, and execute them in a generalized way. So far, WOW has hit state-of-the-art scores on that benchmark. It beats other models when it comes to physical plausibility, temporal consistency, and understanding complex instructions. One of the coolest things the researchers demonstrated is how WOW can be used in areas like novel view synthesis and trajectory-guided video generation. Basically, the model can simulate what an object would look like from another angle, or how it would move in a real physical scene, all with consistent logic behind it. They even showed how WOW can enhance the planning abilities of vision language models by providing simulated feedback, helping them plan tasks more efficiently. The authors of the paper made it clear that this is a crucial step toward building AI systems with genuine physical common sense. When robots have access to massive real-world interaction data, instead of just videos or text, their understanding of cause and effect becomes a lot more grounded. That's the missing link between today's chatbots and tomorrow's embodied intelligence. Robots that don't just see and describe the world, but actually live in it, learn from it, and make independent decisions. Now, while China's pushing Boomy, a $1,370 humanoid for homes and classrooms, the boundaries of robot intelligence on the software side, they're also making serious moves on the hardware front, especially when it comes to price. The country just unveiled what's being called the world's cheapest humanoid robot, and it's not a toy or a proof of concept. It's a real walking, talking humanoid called Boomy, created by a startup named Noi Robotics. Boomy costs only 998 yuan 1370 and stands at just over 3 ft tall, or about 94 cm. It weighs around 12 kilos, so about 2612 lb. It's tiny compared to full-size robots like those from Unitree or UB, but that's the point. Noi isn't trying to compete with the big industrial machines. They're opening a whole new category. Small, lightweight, and affordable humanoids built for education and home use. What's crazy is that despite the size and price, Boomy can walk, balance, and even dance. And it does all that with surprising smoothness. Early videos show it moving with a level of stability you wouldn't expect from something under $1,400. That's cheaper than a flagship iPhone or a high-end drone. The company says this is the first consumer-grade humanoid priced below 10,000 yuan, and it could mark a turning point for the whole industry. Most humanoid robots capable of walking or dynamic motion still cost tens of thousands in China, and even more in the West. Boomy's low price comes from clever design choices: lightweight composite materials, an in-house motion control system, and a modular structure that's easy to repair and customize. It focuses more on engagement and learning than heavy lifting or industrial tasks. Their earlier model, the Noadix N2, already sold over 2,500 units, and even ran a half-marathon for humanoid robots earlier this year, which is wild when you think about it. That success helped them position themselves among China's fastest-rising robotic startups. And with Boomy, they're clearly going after mass adoption. The robot runs on a 48 VT battery, with a capacity of over 3 and 1 to 2 amp hours, giving it about 1 to 2 hours of operation per charge. It's designed to support drag-and-drop graphical programming, so even kids or beginners can code it easily. There's also voice interaction, so it can act like a personal assistant, respond to simple commands, or serve as a learning companion. Noadix plans to open pre-orders between China's Double 11 and Double 2 shopping festivals. That's November 11th through December 12th. A smart move considering it's the country's peak shopping season. They're aiming for the same kind of hype you see with smartphone launches, just for robots this time. The startup itself is new. It was founded in September 2023 by a team from Tsinghua and Zhang University. In less than 2 years, they've gone from academic prototypes to an actual product you can buy for under $1,500. That kind of speed shows how competitive China's robotics ecosystem has become. RoboHub, an independent robotics media outlet, even shared a clip of Boomy dancing and walking. You can see that while it doesn't have the same dexterity or upper body control as larger models, its movement is incredibly smooth for its class. If they can scale this, we could be looking at the first wave of humanoid robots designed for classrooms and households. Not just for showrooms. Unitree G1, small robot, massive strength demonstration in labs. But let's move up the scale a bit from small, friendly robots to one that's showing pure strength and precision. Over at the Beijing Academy of Artificial Intelligence, researchers took Unitree's G1 humanoid and gave it a challenge. Pull a car, and not a toy car, a real one. The G1 weighs just 35 kg and stands at about 132 cm tall. Yet, it managed to pull a vehicle weighing 1,400 kg across a flat surface. Now, granted, the car was on smooth ground, so the friction was low, but still the balance and control required for that are next level. What's impressive isn't just that the robot could move the car, but how it did it. In the video, you can see it leaning back sharply, moving its feet rapidly to maintain traction, and constantly adjusting to stay upright. It's doing all that autonomously. The fact that it can dynamically balance itself while hauling a load that's roughly 40 times its own weight shows how far their motion control and feedback systems have come. And this kind of dynamic balance is key for humanoid robots working in human environments. Think warehouses, factories, or even rescue missions. A robot like the G1 could carry equipment across uneven ground, step over debris, or help move objects without tipping over or losing control. Unit has been known for showing off wild demos, flips, sprints, recoveries after being shoved to the ground. But this test really demonstrates practical control. It's not just for show anymore. You can tell their models are starting to handle real-world physics the way you'd want a reliable machine to. Of course, there are still challenges. Even with all this progress, most humanoid robots struggle with hand dexterity. They can walk, run, or balance. But doing delicate tasks like buttoning a shirt or picking up a fragile object is still far from perfect. Developers are focusing on China's robotics ecosystem moving toward embodied intelligence, making these movements more natural and safe for work environments. But we're probably still a few years away from seeing them rolled out widely in everyday workplaces. What's clear, though, is that China is moving faster than anyone expected. And if this pace continues, 2026 might really be the year when robots can walk into a house, cook a meal, and clean up after themselves. Not because someone programmed every move, but because they actually understand what they're doing. That's all for this one. Thanks for watching.